All right, so well, actually, I can give you guys a few more minutes to fill that. What happened?
Wednesday.
Wednesday and Friday.
So yeah, Wednesday is on.
No. So it's Wednesday and Friday, but you can choose which time you. What happened? Wednesday, Fridays. All right, so well, actually, I can give you guys a few more minutes to fill that. What happened?
Wednesday.
Wednesday and Friday.
So yeah, Wednesday is on.
No. So it's Wednesday and Friday, but you can choose which time you would rather have it. So regardless of which options you pick, it'll still be Wednesday or on Friday. It'll just be at either 9:50 or 12:45.
So, what is your?
It's in the announcement I sent out. EW 267, I believe. Um, so with that, the recording has started. So I will get started. Thursdays, typically, I'll be doing reviews. The office hours are Wednesday and Friday. You can choose which time. Whichever time gets the most votes, I will stick with. Some trig properties are really important in this class. You guys can do it during the break if you want. What happened? Yeah, sure. I'll send out an announcement on whichever one has the most votes, and that's when my office hours will be. So trig rules are some of the trig rules are pretty important in this class. So since everybody can see that, if we start with a basic right triangle, right, and this angle is theta, right, we are going to have O adjacent and hypotenuse, right? A being the adjacent line, it's not theta or O being the opposite from the angle, and H being a hypotenuse. So sine theta will be what? Does anybody know? So it's opposite over hypotenuse for sine, right? Cosine will be right. So cosine will be A over H, and then tangent will be right O over A. So these are really important, especially when you are breaking down force vectors into their x and y components. This will be used. So do be sure to remember these. With that, we also the law of sines and cosines is pretty important for statics. So we have angle A, C, and B with sides A, C, and B. Right? Sides are lowercase, your angles are uppercase. So does anybody remember the law of sines? So yeah, so A over sine A equals B over sine B, which equals C over sine C, right?
That's for any type of triangle, like
Yeah.
lateral or whatever.
Yeah, so for these rules, it must be a right triangle, right?
Yeah.
Your law of sines and your law of cosines don't matter if it is or is not a right triangle. You can use them anyways. So law of cosine, you would have same triangle. You have A, B, C. You have A, B, C, right? You would have A squared equals B squared plus C squared minus 2B C cosine A, right? Would be your first rule. Your second one would be b squared equals a squared plus c squared minus 2ac cosine b, right? And your next one will be c squared equals a squared plus b squared minus 2ab cosine c. Right? So all of these rules right here are pretty important, especially when you are trying to decompose a force into its components. Everybody got those down? Oh, need a few more minutes or a second. Minute. Everybody good? All right, so we'll start with example 2.4 from the book. Right, it is required that the resultant force acting on the eye bolt in the figure to the right be directed along the positive x-axis, and that F2 has a minimum magnitude. Determine this magnitude, the angle theta, and the corresponding resultant force. So if we start here, we can do the triangular method or the parallelogram method of adding together your forces. So you would have this force right here, which would be F2. I'm going to choose to do it the triangular method, so we can move this force to here, right? And then you would have your resultant force here, right? So since we don't really know the angle or the magnitude of this force, we could make a lot of different force, right? So it could look like this, where this would be your F1, this is F2, and this is FR, right? Or it could be like this, where it's a lot less steep, right? So going by what we know about triangles, we can say that this F2 line will have the shortest length when we have a 90-degree angle with the resultant force, right? So that means we can say that this line right here will have the lowest magnitude, right? So with that, we can break apart the forces, right? And we can label the angles. So we know that this is 60 from the figure here. So we have 60, we have that theta, and then we would have to solve for F2, right? So we can say that FR would equal 800 times that cosine 60, right? Because the cosine would be the adjacent vector from this 60 degrees, which would be that FR value. So if we do this on a calculator, we will get 400 newtons, because this is 800 newtons, and your cosine is dimensionless, right? So we would have 800 newtons times cosine 60, which would be 400 newtons. And then we can also say that if we take the sine of 60, right, that's going to be the vector opposing the 60 degrees angle. So we can say that F2 will equal 800, and you would have your newtons, times sine of 60 degrees, which should be 693 newtons if you plug it into the calculator. So with that, we have found the FR and the F2 value, right? And then we said that the theta will be 90 degrees, will make the angle minimized, right? Or the force magnitude minimized. So we have our theta, we have our F2, and we have our R2. So that would be the magnitude, the angle, and the corresponding resultant force. So we know that we are done with this example. Does that make sense to everyone?
Just because it says F2 has a minimum magnitude, that's why you're able to make it a right triangle?
Well, yeah. So if you notice on this graph or this plot, I took it from the book because they draw it a lot better than I would ever be able to. But if you notice, this F2 on this one right here is a lot shorter than any of the other ones, right? So this one would be longer, this one would be longer, and this one would be longer. So we can conclude from this that F2 is minimized when we have that 90-degree angle.
So you just assume that it's 90, or did you do like a calculation?
I mean, well, you could do the calculations on each of these, right? So you have, you would have you can do it over again with, you can say that this is, I don't know, 120, right? And then that would make this angle over here, it would make that what? Actually, you can't use 120 because that would make it a non-solid of a triangle. You can make this 110, right? Which will make this angle 10 degrees here, right? And you can resolve it, and you will find that your force is larger than that 90-degree angle. Make sense, everyone? No? What are you confused on?
What was the question asking?
The question was asking, it asks you to find the F2 if it's directed along a positive x-axis, and it wants the magnitude of that force with the angle. So that angle would be that 90 degrees to make it minimum. So that's the first part of it.
So it's asking, so for the minimum, that's why you know to make it 90
Correct,
degrees?
yeah.
Oh.
So if it's asking for something else, let's say it asks for angle to be theta equals something, then you would solve it like that. But since it is asking for the minimum, we can assume that theta should be 90. Yes.
Every time they ask for a minimum, you just assume it's 90.
Well, you would have to make a similar figure to this, right? And then by inspection, you can tell that F2 is minimum at 90. It might not always be like this. Typically, it will be, but not always, right? All right. So with that, we can go on to example 2.5, right?
It also has to solve for theta.
Right. So that theta is that 90
Oh, I see.
here, right? And then it asks for the force resultant, which would be this. Oopsie. It would be this one. Okay. And then it also asks for that F2 value, which is the unknown force that we minimized because of that 90-degree theta value. So that would be all three parts of the question. Right, so with that, we can go to example 2.5. Right, this one's also from the book, but I will walk through it with you guys. That way everybody understands it. So in this one, we're supposed to determine the x and y components of F1 and F2, acting on the boom shown in the figure below. Express each force as a Cartesian vector, right? So in this example, we can break the forces apart, right, into their x and y components. So if we notice, this is the x-axis, right, and this is the x, and this is the y, right? So you can say that since F1 acts along both axes, we can break this apart into it. Let me change. Did it just stop? Okay. Nope. Okay. So I can break this apart into its F1 of x and F1 of y values, right? And when we add these two together, it should still equal our F1 in that 30 degree from the y-axis value, right? So we can say that F1 of x will equal negative 200, right? And then I should have either a cosine or sine of that 30 degree angle, right? Who can tell me which one it should be?
Sine.
Right. So the sine would be, so if we were to move these angles so they're here, right? We're looking for these two red lines, or red forces, right? So you would do the sine because it would be the opposite one of that. So we would have 200 sine of 30, right? And then what are units? Right, newtons. So sine is dimensionless, so we know we keep the newtons as the unit. So then negative 200 times sine 30 will be negative 100. And then we have our newtons. And then depending on how we want to set up sorry, I forgot the way. But depending on how we want to set up let's say, so we can say that the x in the right direction is our positive, right? And we can say that the y in the up direction is our positive values, right? This is convention, for most problems, we always want to keep that right word positive and that up positive, right? So that makes left in the x direction negative and down in the y direction negative, right? So we usually try to keep these conventions through each problem. That way, it doesn't get confusing as to what negative and positive mean. So this negative 100 in the x would mean that we're going left, right? So we can either display it as F1 of x equals negative 100 newtons, right? Or we can say that this force is going left, and then we can say that F1x equals 100 newtons, right? So both are correct ways of displaying information, depends on just how you want to write it. So then we can do the F1 of y force, right? And we have 200, and then what would this 200 be multiplied by, sine or cosine? Right, so we have 200 of cosine 30. And then would this be a positive or a negative force? Right, because we're going up. So when you do that in your calculator, we would have 173 newtons, right? And then for the F2 force, right? We're not given this theta angle. We're given this triangle, right? So we assume that this is a right triangle, right? So we would have 5 in the y and then 12 in the x direction, right? And then that would be 13. So we can use this triangle instead of the angle to determine the way that the force will go in the x and y direction. So if we make the claim that f of 2x over your direction, right, will equal 12 over 13, right? Because that would be, so the 12 is in the x direction. So if we have 12 over 13, that would be the cosine, right? Or the cosine equivalent, rather, of that triangle. So when we solve for that f2x, we're going to get 260 times 12 over 13, which is going to be your adjacent over the hypotenuse. So we know that's the right angle because we are looking for the cosine. And that's going to be 240, right? And then what are the units? Right. And then it's going to be positive because we're going in the right direction, right? So then we can also do the same thing for the Fy, right? Would equal 260, and then who can tell me what the relation is going to be here? Which one over which? Right, so that's going to describe your y direction. So when you do that out on your calculator, you're going to get 100 newtons, right? So determine the x and y components of the F1 and F2 force acting on the beam. So we did that, right?
This just do like arc cosine and then find the angle and then do it the way we did on the first.
Yeah, you can. That is definitely a valid way to do it. The only issue you might run into is that 5, 12, 13 is a special right triangle, right? So when you do that, when you find the angles, it's going to be some decimal number, right? And it's going to be hard to work with. So instead of trying to work with those numbers, we can use the fractional proportions, which is going to make your life easier, in my opinion. But you can do it the other way, right?
What's the fractional proportion? F2 of x over 260.
Right, so this is just before you would do this. So this, in its nature, would be your 12 over 13 would be the x direction over the hypotenuse, right? Which would be your cosine angle, right? And so it's just saying it's the same as cosine. Yes.
So the angle of the, would it be -90
What happened? So if you wanted to find the angle, right, we can make this triangle bigger, and we would have 5, 12, and 13, right? This is your 90 degrees. So I didn't do this before. But if you have your calculator, right, you can say that your cosine is going to be what? Arc cosine is going to be what? If we're looking for this theta value. Right. So if we do cosine, or arc cosine of 12 over 13, we are going to get 22.61986495, right? So it's going to be an ugly angle to work with, which is why we don't do that.
Would it be 5/13? Oh, that would have been the opposite of theta. That would have been the other half.
Right. So if you said theta was this one, then it would be pi over 13, right? But since we are saying this is theta, it is 12/13.
Would that be the same thing as that theta up there?
So yeah, it should be the same. But again, you don't want to work with 22.619864, right? So that's why we do keep it as a triangular method, right? With that triangle there.
But if you were to get the other angle, that one at the part is point here up. Like the part of the angle for in between 5 and 13, would you then take your answer and subtract it from 90?
Well, you can say that this angle here would be theta, or 90 minus theta, right? If that's what you're asking. Yeah, this would be 90 minus theta, and you can do it with sine and cosine. But like I say, it would be easier to do it with the triangles. Yes.
The second force, right?
Yes.
Wouldn't they be like opposite sides? One would be negative, the other would be positive.
Right. So yeah, this one would in fact be negative 100 newtons if you're keeping the positive. Yeah, good catch. Axis.
And you have to write it in Carson vector form.
Um,
So would F1 be negative under I?
yeah. If you wanted to do it like that.
I was just saying, 'cause the question asked for that.
Yeah, I did look in the back of the book. The question had these the four answers.
But I didn't write it.
I'm not sure why I didn't write it, but yeah, if you want to do f of 1, then you would break it apart into your negative 100. That would be the I, right? And then plus 200j. And this would be f2 of 240 minus 100j, right? All right, so going on to the next example, example 2.7. I'll do this last one, and then I'll put an example on the board. Let you guys see if you can do it on your own. So example 2.7, we are, the end of the boom O in the figure below is subject to 3 concurrent and coplanar forces, right? Determine the magnitude and direction of the resultant force. So keeping the sign convention, rightward positive and upward positive, right? We can determine the sum of forces in the F and Y direction, right? And then we can find the resultant force from there. So if I say that the upward or the rightward plus sum of forces in the X direction, right? I'm gonna say force resultant of X. So what would that be? Does anybody know? Want to take a guess?
400, negative 400.
Right. So negative 400, and then plus. Plus. Well, let's do F2 next, right? So plus what? 250 what?
Negative 240 sine 45.
So this 250 is going in the right direction.
Oh,
So
yeah,
this would be positive, right? So yes, it would be plus 250 sine 45, right? And then we would, so this force is going to be minus or positive, this F. Right, minus 200. And then again, we have this triangle here, so we can do 4 over 5, right? It's going to give you your equivalent cosine if you were doing it the cosine method, right? Because you would have adjacent over hypotenuse, which would be equivalent to the cosine. All right, so if we were to plug this all into a calculator, we're going to get negative 38. Or negative 383.223. And what are units here? Newtons, right? And then we're going to have the upward positive sum of forces in the y direction, right? So who can tell me what these would be? Would I have anything for the F1 force? No, because it acts directly along the x-axis, right? So there is no y component. So that means that I would look at the F2 force, right? So would that be positive or negative? Right, so positive 250, and then what would go with it? Right. And then you would have that plus 200, and then you would do the sine equivalent, right? So that'd be opposite over hypotenuse, which would be 3 over 5, right? So when you plug that into your calculator, you're going to get 296.8 newtons, right, in the positive direction. So that means we can write our forces on this. Choose orange. So we know we're going to have FR, right, in the Y as that, so it was 296.8, and then we're going to have Fx in which direction? Right, so it's going to be going to the left, right? So that's going to be FRX, right? So we know that our resultant force is going to look somewhere like this, right? It's not 100% accurate, but we know it's going to go in this general direction, right? So what we can do is we can, instead of writing this along the y-axis, we could, select everything. We could move this up here, right? To create our triangle with a 90-degree angle here, right? So that means that we can then use the, so we can say that FR equals the square root of FRX squared plus FRY squared, right? So then we would just plug in our Fx and Fy values and square them inside the square root. So that will give us 485 newtons, right? So I did most of the math in the calculator before this. So you can check the answer, you'll get the same thing. I just don't want to spend time sitting here plugging into the calculator. So then our theta angle, right, is going to be, so how would I find the theta angle? Assuming I don't know this FR, right? FRX is the FRY, right? So theta will be inverse tangent, right? And then what would we have? Would y or x go on top? Right, so the inverse tangent y over x, right? So you can say Fy over Fx, right? You plug that in, you're going to get tangent negative 1 of 296.8 over 3.2, right? And then you are going to have 37.8 degrees, right? So that's going to give you your dimension of the theta value. Yes. The right direction in the x is positive, the left is negative. Right, so we considered a convention to go right positive, up positive, right? Just so that way, if you have 10 people working on the same problem, you're not going to get a bunch of different answers, right? All your answers are going to be the same because they're all in the same, they're all in the same directions, right? Yes. Right, so we would be looking for the direction of the resultant force. So, so that would be this angle right here, right? So it would be from the vertical angle.
Why did you determine that it's from the perspective?
Because that would be the triangle, right? Because tangent would be y over x, right? So this is our y. This is our triangle here, the orange, and then you have your theta value. So y would be this, right? And x would be the other one. Yes. What happened? Oh, you mean for here? Just because it's easier to work with the triangle instead of the angle. Because again, if you put this into your calculator, you get some long decimal, right? We don't want to work with a long decimal. So we just keep it as a triangle, and it saves us a lot of time. Yes. Because we have this force, right? And it tells you this is. So I'm just making this F3 line bigger, right? So we have 3, 4, and 5, right? So this is our triangle, right? So if we call this one theta, right? This is for the x, right? So we know that cosine is going to be your 4 over 5, right? Because it's adjacent to our hypotenuse. So instead of doing this inverse cosine, we can just say that this is 4 over 5 will give us the same thing, right? And
How did you know that it's a 2
what?
How did you know it's a 2
Will that always be good?
What?
Yeah, is that
The problem will always give you enough information to solve it, right? So it'll either give you that angle or that triangle. If it gives you the angle, you're going to use cosine and sine. If it gives you that triangle, you're going to use trigonometry to solve it, right? And break down your forces. So this one here is the fundamental problem, 2-1, right? So this one we're supposed to be determining the magnitude of the resultant force and its direction measured clockwise from the positive x-axis, right? So I'll let you guys try this one on your own, see if anybody can come up with an answer, right? And then I'll walk around in a second and see if anybody's getting close. So how do you think you guys would go about solving this? Like, what would you do? Anybody know? Yeah, you can break it down into your two forces, right? So once you have your picture, what? Yes, you. Right. So you would break it into fx resultant and fy resultant, right? And then where you go from there? Right. So you would do the square root of the forces, right? So you just the square root of f resultant x squared plus f resultant y squared, right? And then you would find your theta, right? And then, so this one, it does want the direction measured clockwise from the positive x-axis, right? So you definitely have to consider which direction you're finding your theta in. And if it's not the correct direction, you have to flip it around, right? So it looks like a lot of you are making some pretty good progress. So this one would be example 4 from today, right? I'll put the 4 from the top, right? So if we were to break apart this first force on the left here, right? If we finish up this triangle, this angle here would be 60, right? So for the x direction, this would be the cosine, right? And then this one would be the sine. So it is important you use the right cosine and sine ones. If you do it backwards, you get the entirely wrong answer. So it is important that you do know which one is cosine and sine, right? So if I do the rightward plus sum of forces in the fx direction, right? I'm going to get negative 6 cosine 60, right? And I'm going to have plus, what is the other force going to be? Correct. So that's going to be 2 cosine 45, right? And when I plug that into a calculator, I'm going to get negative 1.58578. And then what's going to be your, right, you're going to have kilonewtons instead of newtons this time, right? So then if we do the upward plus of forces in the y, we're going to get, what it will be the equation?
-2 sine 45.
So if we complete this triangle here, right, this is going to be your 45-degree angle. So again, here too, your cosine is going to be this adjacent angle, right? So the cosine is going to describe the x, and your sine is going to describe the y.
Can you just ask for sine or for y?
Um,
In the negative y direction.
oh, did you
Just
say
ask for
sine?
the y component?
Oh, did you say? I thought I heard cosine. Sorry, that was my bad. Right, so you would have negative 6 sine 60, and then plus 2 sine 45. That's going to be minus, right? Because they're both going downwards. So when you do that out, you're going to have negative 6.610366, again, kilonewtons, right? So with that, you're going to use this equation right here. So your FR is going to be this, right? When you plug them in, you are going to get 6.8 kilonewtons, right? So if I, oh, that was really not straight. If I have the x and I have the y, right? It's going to be your y, it's going to be your x. We know that the Fy is going to go down, right? See that? Go down, right? And we know that Fx is going to go this way. So we know our force is going to look like this, right? So if we therefore say that this value is theta right here, right? We are going to have your theta, right, equals inverse tangent of your Fy over Fx, right? With what happened?
How do you know that angle's
I mean, in reality, you can say either one is theta, right? It's just going to change the way you plug it in, right? So if I call this one theta, this one's going to come here, right? So theta is what? Opposite over adjacent, right? So this is your y, and this is your x, right? So opposite over adjacent is going to be Fy over Fx. Right? But if you plug it in the other way, right? Let's say you do this one. This is gonna be theta. And this is gonna be here. So now the opposite is which one? Right. So so you're going to plug it in the opposite direction, right? As long as you make sure you account for your assumptions, you will tend to get the right answer. So because I assumed the orange, I made the equations match what the orange would be. If I assumed green, then I would make it match what green would be, right? Will it connect? No. There we go. All right, so since I'm assuming orange, I'm going to have theta equals Fy over Fx, right? And then I am going to plug in the values. I'm going to get 76.51, right? And this will be in what units? Right. So because I assumed that it would be this way, right? This angle would be from this direction, right? Which would be the counterclockwise direction. But the question is asking for our direction measured in the clockwise direction, right? So if I have a straight line, its degree value will be what? Right. So we're going to have 180, and then it's going to go this way. So this value was 76.51, I said? Yeah, I won. So this right here is going to be your 180 minus 76.51, right? Which is going to get you 103.48 degrees, right? Oh, 0.9, I meant. Yes.
If you left it in counterclockwise, you have to add 180 to it.
So if I had assumed the green line, right, then I would have some angle from here. We're going to call it theta 2, right? So that means this angle right here would be 90. So clockwise from the x would be theta 2 plus 90.
Yeah, I was just asking, like, since it, if you left it with the orange one, like 76.51, technically, isn't that in the third quadrant? So wouldn't you just add 180 to it? Because that's like the 256 degrees. You know what I'm saying?
I
From the
actually,
positive x-axis going around.
right, so we usually go from, yeah, you don't go to that, you always go from the, yes.
There are a lot of situations where they'll ask for clockwise from the x-axis.
100% up to the question. I've seen most of it. I've seen clockwise from the y, clockwise from the x, counterclockwise from the y, counterclockwise from the x. It just depends on what the question is looking for, right? So, yes.
How did you determine that the theta was third quadrant?
How did I determine the theta was? So we know that the force is going to be your Fx is going to be to the left, right, and your Fy is going to be down. So you can move those forces through your triangle method, right? So in theory, the forces would start at the origin, right, and this would be your Fy going down, right? But we can add it head to tail, and then we're going to move it here, right? Because we're just going to shift it left, which is going to give us this triangle, and then we can choose any angle to be theta, really, as long as we stick with it and we follow our convention that we made for this problem, right? Any other questions? All right. Guys, over 150, so I guess now's a good time for a 10-minute break, and then we will resume after that.
I was trying to do it by myself, but when I make my triangle, I guess this might force to, so I just draw it parallel to it. Right, so if I do the triangle thing, the F2 will be like right here, right? Or would it be like here?
Well, you're not adding these two vectors are different from one another, right?
Hmm.
You're only doing the triangle method for the F resultant force, which is the same one,
Got it.
but we break it into an X and Y component.
Got it. Makes sense.
What happened? Right. So the clockwise from the X is only for the resultant force, right? But each one, the 6 kilonewtons and the 2 kilonewtons have their own dimensioning defined by the problem, right? So that 60 and 45 are completely independent from your resultant force.
Instead of making 6 like 6 coincided and 8
I mean, it doesn't really make sense to do that just because it would make your life so much harder. You could technically make another force. Like, you could technically make a triangle anywhere, and as long as you follow that triangle you made, you'll get the right answer. But it just wouldn't really make sense to do it for this problem. Yes. Right, yeah. So that's definitely one way to do it, right? All right, so I think most of you are back. So I'll continue with this problem, right? So if we define our y going this way, right, and our x going this way, then we have these two forces. So one way to do this would definitely be to say that this is one force, right? And the angle from here to here would be that 70 degrees, right? Otherwise, you can say that this would be a 90-degree angle because it's the xy intersection, right? So you could say that since this is 70, this one would be 20, right? And you can solve them independently of each other. So it doesn't matter which way you do it. Both ways are valid. I'll give you guys some time to try this one out on your own, and then we can do this one if anybody wants me to go over it. This question, that's a good question. This question is asking for the magnitude of the resultant force if both forces act on that hook.
Wait, what was the last part?
It's two forces act on the hook, determine the magnitude of the resultant force. Can I write on this one? Oh, this one doesn't work. Yeah, just the magnitude. Why do they have a pen here if the pen doesn't work? I guess. Yeah, this doesn't work. Come on. There you go. Pull it out.
You do this like this similar to the last one?
Right, where you would sum the forces in the x and y direction, and then you can use a square root to combine it, right? So anybody come up with an FRX and FRY yet? What'd you get?
FRX 344 joules.
Right.
FRY minus 569.8
Anybody want me to go over it, or? Alright, so fx would be 200, right? Cosine 30, and then it would be plus 500 cosine 70, right? I'm going to use that 70-degree angle instead of trying to do it from the y-axis. I'd rather do it from that 70-degree mark. So then when you... Oh, sorry, this is... No, wait, no, that's me. I'm looking at the wrong line. This would equal 344, right? When I did it, I got 344.215. But obviously, you can round it to the nearest Newton. Unless it specifies otherwise, it doesn't really matter. Just don't round it like anything ridiculous, you know? Typically, I like 2 decimal places out. It just gives you the best answers, I think. But of course, you can round it to the nearest Newton if you want. So then your Fy would be negative 200 sine 30, right? And then your negative 500 sine 70, right? And then that's going to give you a negative 569.85, or 846, right? So you could round that to 569.85 is what I would probably do. That's be 344.22 newtons, right? So this one would be in the positive, x direction, right? And this one would be in the negative y direction because it's that negative force, right? So we could choose to rewrite it as positive 569.85 newtons, and then specify that it does go in the downward direction, which would be a valid way of writing it. But again, up to how you want to display the information, right? So with that, you would use your FR equals the square root of sum of forces. The sum of forces in the y plus sum of forces in the x, right? Squared. You do out that math, you're gonna get 666 newtons. This one I rounded, just because. Yes.
Can you just, you know how you wrote out the formula for FR?
Yes.
Can you write out the formula for the sums? Does that make sense?
You mean this part right here?
Yeah.
Oh, you want to know, like, okay, I got you. So you would have F1, well, you wouldn't, I mean, I guess you can just call this F1, right, and we'll call this F2. Doesn't really matter as long as I keep it consistent, right? F1, so you would have, so F1x would be what? Can we answer? All right, 200 cosine 30. And then F2x is going to be what?
Negative 500 cosine 70.
Well, this would be the x.
500
Right,
cosine
right. So 500. Yeah, I agree. Cosine 70, right? And then your F1y, right, is going to be what? Cosine 30, right? And we're going to put that negative sign there because we're saying that going down is negative, right? And then your F2y is going to be that negative 500 sine 70, right? Yes, another question? What happened? So, which arrows? Oh, yes, you are correct, yeah. Yeah. Good? So, just make sure you write the right arrows in the right places. All right, so we have fundamental problem 2.4. Problem 6 for today, right? Oh, that's way too big. Problem 6 for today, right? So we have, they want us to resolve the 30-pound force into components along the U and V axes and determine the magnitude of each of these components. So this one's definitely a lot harder of a question, right? This one I would definitely suggest the parallelogram method of vector addition, right? So we could make this the V, right? And we make this the U. And then we can move that V up here, right? Or the U up there, and we'll move the V over here, right? If it will let me move it. There we go, and that's V, and that's U, right? So then that force is going to be in the middle and hit that center, right? So from there, we can label what we know, right? So if this is a 30-degree angle, right, and there's a 15-degree angle, what would this one be in the middle here? This one would be 45, right? So that means we can say that this one is 45, right? And this one up here is what? Right. And then we can say that the two corner angles are going to be what?
15.
Right, 105. sum of all interior angles of the triangle is 180, right? So that means we can do law of sines, right? So we call this force is 30, right? So we know the length of this middle. Where's my? Oh, the length of this middle section right here, right? So that means that 30 over sine 105 is going to be equal to what? We can say that this would be an FU force and an FV force, right? So that 30 over sine 105 is going to be equal to the FU force over sine 45, right? And then that means that if you plug this into a calculator, you're going to get FU equals 22.0 lb, right? Because it does give you that. It says 30 pound force, right? So this one would be in the US units instead of the metric units. So then how would I find FV? Can anybody tell me? Right, so you use law of sines to do what? So if we start with that 30 over sine 105, what are we going to have on the other side? Right, so we're going to have FV over sine 30, right? And that's going to mean that FV equals 15.5, and our units are, right, pounds. And that's this problem. Do you have any questions on this one? So wow, this one's long. So we can go on to problem 7 of the day. Yes. Yeah. This one. If you have the 14th edition, I'm not sure if the chances are they are in the book. No, they're not.
Absolutely are. They're page 28.
All right. So if you are they labeled as the exact same thing?
This one is
This one will be F2-4. Is it the same? Yeah. So I have noticed that if you have different generations of the book, they do scramble the problems. Usually it's not entirely different problems. It'll just be, so like problem 1 will be like problem 10, right? That way they can charge you another $150 for a new book, right? So that's how they get you. But yeah, so these problems should all appear in a earlier generation. It just might be in a different place, right? Or maybe some slightly different numbers or something like that. Right? But the general concept should still be the same. Oh, you're still copying it?
Yeah.
All right. Yeah, I don't have any issues if you guys want to like take pictures or anything. I know it can get a little fast, so you just want to like take a picture, and then you can copy it down later. You know. All right, so problem 7 for the day, F2-5 in the book. The force F is 450 pounds, acts on the frame. Resolve this force into components acting along members A, B, and AC. Determine the magnitude of each component. So who thinks they have an idea on how we would go about this one? Right, so you could, label, I'm going to say this is my Y, right? Let me change it to blue. I'm going to say this is my Y, right? And this is my X. So what would be the logical next step, you guys think? Yes.
Label the angle between C and the negative X, possibly.
Yeah, okay, so what do you guys think that angle would be?
15.
All right, yeah, that would be 15. And you could also say that this big angle here would be what?
75.
Right, and then this tiny angle here would be? Right. So now that we've labeled all the angles and axes, what do you think we do? So on this one, I would suggest breaking it apart, right? We know that that members AC and AB are going to have some kind of force in them, right? So instead of drawing out the members themselves, we can just break that into a force, right? So we can say that FAC is going to act along this member, right? And we can say that FAB is going to act that way, right? And then we have that negative 140, or negative 450, sorry, that acts in a directly downward force, right? And then we, of course, have our 45 here, the 15 here, 30 here, and 75 here, right? So all I did was just redraw it so it looks like forces instead of a picture, right? So, so we can say that since this member doesn't move, right, that the sum of forces in the x direction are 0, right, and the sum of forces in the y direction are 0. It's just assumed that it's in steady state, unless it says, you know, this member is moving, and then you have to consider that. If it doesn't directly say that, you can pretty much assume it's stationary, right? Yes.
But wouldn't you obviously think the Y moves because the way the fence.
Not really. Like if it said, you know, when you apply this force, it changes by some degrees, right? The A point goes down by like 50 feet, right? Then you would know it's changing because it gives you that information. But unless it specifically gives you that information, there will be no way to solve this whatsoever, unless it said like, oh, hey, this moves in like a this way direction. When it starts to move, it's definitely in later classes. It'll get a lot more difficult than this. But for right now, we can basically assume that most questions are in steady state, unless specifically said otherwise. Right? Otherwise, this wouldn't be solvable with the information you guys know right now. So assuming it doesn't move, right, your sum of forces in the x is going to be 0, because if there's a force on it, right, so if you push with like 10 pounds, right, it's going to move, right? So there has to be something that balances out that 10-pound force to give you a net force of 0 on the object, right? You push down on a table, the table exerts 10 pounds onto where you're pushing, right? So we're going to say that the sum of forces in both directions is 0, meaning it does not move, right? So that means you can say that, so what forces do you have in the x direction then? Well, you would still have forces, right? You would have this force and this force, right? So you can say that negative FAC cosine 15 minus FAB sine 45, right, is going to equal 0. So this half of it should be what we've been doing, right? 1 through 6. Just breaking down your forces into x and y direction. The only new part is that it now equals 0, right? So that would be that section. Right? And then we can move this over here a little bit. And then your Fy is going to be negative FAC sine 15, right? And then minus FAB cosine 45, right? And you have that minus 450. And then you're going to say that all equals 0, right? Everything makes sense so far? So what you can do is you can rearrange the right side. Well, if I divide everything by -1, right, we're going to have FAC sine 15 minus plus FAB, right? Cosine 45 plus 450 equals 0, right? And then, yes.
I'm so sorry. Why are we using different trig properties for FAB? I didn't catch that part.
So FAB would be this force, right? So we can say that your sine of 45 is going to be, so we complete this triangle, and this is 45, right? your sine of 45 is going to be this one, right? And the cosine is going to be this one, because the cosine is next to the angle, and the sine is opposing the angle.
Okay.
Yeah.
Sorry.
No, you're good. Yeah, got any questions to ask? So,
You could also use the opposite, right? Because 45 degrees the other way.
what do you mean the other way?
Sine of 45 equals cosine of 45.
Oh, yeah, you could. But the issue with that is that if it is not, the 45 is a very specific case where it is equal, right? If it's not, then you would run into the wrong answer, right? So only in this case can you do that without.
If you knew the opposite angle, then you
Yeah. So I mean, you could technically finish the triangle here, right?
yeah.
And then this would still be 45. So in this very specific case, it doesn't matter which one you use. But for other cases, it will definitely matter which one you use. So we always try to use the right one. That way, if it does matter, we're still fine. Why is it positive in the y? What do you mean? Oh, you mean why are all the terms positive now?
Yeah.
I just divide everything by -1.
Okay, true.
Right, so 0 divided by -1 is still 0. So it doesn't matter what we do to the equation as long as it stays the same, right?
Yeah.
So with that, I can rearrange this equation, FAC sine 15, right? Plus FAB cosine 45 equals negative 450, right? Right, so now what would be the next logical step with this information we have? I'm looking for FAB, AC and FAB, right? So how would I find that, do you guys think?
Did you use substitution?
All right, you would do substitution. So you have two equations. I mean, you could technically do elimination. It would definitely be a lot harder with the cosine and sine there, so I wouldn't recommend it. But let's say let me follow what I did here. That way I don't have to use the calculator to figure it out again. So I say that I want to rearrange this one, right? I have negative FAB sine 45 equals negative or positive FAC cosine 15, right? And then to get that FAB by itself, I'm going to divide by negative sine 45, right? So I'm going to have FAB equals negative FAC cosine 15 over sine 45, right? And then I can plug in this FAB into the FAC, right? Or FAB on this side over here. So I would have FAC sine 15 minus FAC cosine 15 over sine 45 equals negative 450, right? So then if I want to, so I can combine these, right? If I factor out that FAC.
Why did we assume they're equal
What do you mean?
before the FAB, negative FAB sine 45 equals FAC cosine 15? Why did we assume that those are equal to each other?
He's just
Well, I have two equations. This one and this one down here, right? I can say that FAC is equal to FAC regardless of which equation you're in, right? It's the same member, so it has the same force. And so I say that FAB is equivalent no matter which equation you're looking at, right? So you have two system of equations like x plus y and 2x plus 2y, right? Normally you can solve through either elimination or substitution. With the sine and cosines, it's pretty difficult, in my opinion, to solve by elimination, right? So I chose to do a substitution. So I would solve the left side for either FAC or FAB, doesn't matter which one you do, and you plug it into the right side to then solve for your remaining variable, right? Yes.
Yeah, I think it's just if FAB is negative FAC cosine 15 over sine 45, then that be multiplied times cosine 45.
What happened?
You're just substituting for FAB, right?
Right,
So
right.
then if you plug it in, don't you have to multiply by cosine, that whole thing by cosine 45?
Oh, yes, you are correct.
Because that looked like you got it.
Yeah, I did. Yeah, good catch. There should be a cosine there, so I would have cosine 15 cosine 45, right? Equals negative 450. Math checks out now. So then you could group these together, right? So you have sine 15 minus cosine 15 cosine 45 over sine 45 equals negative 450, right? I can set this whole thing, right? Let's say equals alpha. Right? Now I don't have to keep writing it out. So then I can say that FAC alpha equals negative 450. Right? So FAC equals negative 450 for that alpha term, and then FAC equals 636.396 LB. Right, so this from here it would be this algebra, right? You can if you plug that whole thing into your calculator, you're gonna get a constant value, and then you divide negative 450 by that constant value, and you get 636.396. So after that, right, we can choose to plug FAC back into here, right? And you can solve for FAB by just plugging it in, right? Because cosine and sine will be a constant value. So you're going to get that it's going to be negative 869.333, right? So later on in the course, it's going to matter what the sign is, right? So negative is going to be compression, positive is going to be pulling it out, right? So for right now, though, it's just looking for the magnitude of that force, and we want to give that in a positive value because it doesn't matter where. Right now, it doesn't matter how that force is being applied. We just want to know what force is being applied. Make sense to everybody? Questions? Concerns? Comments? What happened? Alright, yeah. In theory, yes.
Is that probably the easiest way?
It just makes your life a lot harder. There's just no reason to do that. Also, you have to find a whole new set of angles because your axis is really going different ways, and then so it just adds a lot of confusion you just don't need. Right. All right. So problem number 8 for today. All right. If force F is to have a component along the u-axis of Fu equals 6 kilonewtons, determine the magnitude of F and the magnitude of its component V along the v-axis, right? So this one would be like, which one did I do? That was like this. It would be like that F2-4, right? You would solve it in the same way. Make a parallelogram, fill out the angles you know, and use the law of sines to solve it. So I'll let you all try that, and then we can do it together. guess the professor's only showing up to half my lectures. Yeah, he's gone. Yeah, he was sitting in the back for the first before the break. Yeah, I don't know. I think he was. What did everybody put their opinion for office hours? Alright. What happened? No, my office hours are Wednesday, Friday. I said I wanted to have them on in the morning, 9:50 to 10:50. The professor said they would be better at 12:45 to 1:45. So I was like, put it to a vote, see what the class thinks. So yeah, if you want to voice your opinions on when my office hours should be, page up here. All right, so I guess I'll do this question to you. So we can say that we are going to have a force here, right? That's going to be our Fu, and the force here, which is going to be the Fv, right? So if I were to translate these over, something like this, right? Even with a computer, I can barely draw these. That goes there. So this would be your Fv, this would be your Fu, right? So that means you have a parallelogram. Looks something like this. And then, so this angle would be your 45, right? And if this is 150 over here, the whole thing, and you take away that, or is that, no, this is 105 here. And then this one will be 45, right? So you 105. So what would your last angle be? Anybody tell me? Right, 30 here. So we have f over sine 30 is going to equal fu over sine 105, right? And then fv over sine 45, right? Law of sines. So that means you can isolate two parts of it, right? And then solve for each one individually. So we would have f over sine 30 equals fu over sine 105. And then we'd have f sine 30 equals fv, right, over sine 45. Right? Yes. So that would go back to the law of sines, right? This one right here. Use the angles. So the length of the side opposite the sine of its angle will equal to the length of the side over the sine of the angle, right? So it's just a matter of applying that to this particular problem. Which I said these are important to know how to do. Which one was I on? This one, right? So then we can do this, right? And then you would solve for the forces. So we know Fu equals 6, right? So they give you this one right here, right? So instead of doing this, which I have right here, right? I'm going to change this to Fu, right? That way my answer is more exact, right? Because if I go off a rounded answer, it's going to make my next answer less and less precise, right? So it's always better to go with an exact number instead of your rounded number, right? So if I instead did right, so you can choose any of these three and set one equal to the other, right? But the issue is if I did F over sine 30 equals F V. Oh wait, so I would have changed this too, right? 105.
Yeah.
So if I did FV over sine 45, right? This F would already be an approximated value because we would have to find it from here and then we would round it, right? So if we use a rounded value, that's going to make our answer for FV less exact. So instead of doing that, we can use the FU, which we know is an exact value, and get a more precise answer, right? You just gotta make sure you change the bottom half of it. That was helpful. So that means if you solve it, you get F equals 3.106 kilonewtons, right? And then FV equals 4.392 kilonewtons. Right?
You get that by plugging in 6.
Well, yeah, so it tells you up here that FU equals 6, right? So we plug that into here, then we have 6 divided by sine 105. And then, so we have F equals sine 30 times 6 over sine 105, right? Yes.
So it's supposed to be the same thing next to each other.
What do you mean, same thing?
The second one, what you have over FD. Because you have everything ran twice.
Oh, yeah, FE over sine 45, right? All good with the math now? Right, so yes, looks good. Everybody good? Any questions? Math all right? Okay, so yeah, sure. Everybody got the picture? Yeah. All right. Got a picture? All right. So FV is 4.392. F is 3.106, and both units are in kilonewtons. Okay. All right. So problem 9 for today. Determine. Oh wait, which one am I doing? I'm doing 2.5. Right. So we're supposed to determine the magnitudes of the two components of F along members A, B, and AC, with F equals 350. Right. Newtons. So it gives you this figure. Right. So who knows how we would go about solving this one? Any guesses?
Similar to the one we did before that last problem?
This one definitely has a less complex solution. So if we were to finish up this triangle, right, we can say that this would make a triangle here. Right, and then that would be 30. So we know that this is 350 here, right? And then we can say that AC equals f cosine of 60, right? Because this would be a 90-degree angle here. So I can assign, well, I tell you what, we can do sine f equals sine of 30, right? AC equals f sine 30. No, that wouldn't be right either. Not bad. So we have a triangle here, right? That would be 30. Oh, so you can call this angle 60, right? So AC is that cosine value. AC is your 350, cosine 60. Because we're pulling it from here, right? So you would just solve for AC. Because I did not do that yet. 350 times cosine 60 would give you 175. Right? And then your AB, you can relate it to
Could we just do the same thing?
right. Yeah, you could do that. So you could have F sine 60, right? You should make this 350. Multiply it by that, and you would get 303.1 lb, right? Yeah, I didn't like this one very much. I don't know, tell you either. All right, so question 10. Determine the magnitude of the resultant force Fr equals F1 plus F3, and its orientation theta measured counterclockwise from the positive x-axis. So what would we do in this situation here? Anybody know? Yeah. Got a picture? All right. So what would we do here? Anybody know?
What is it asking for?
It's asking for Fr equals F1 plus F3 and its orientation counterclockwise from the positive x-axis. So in this problem right here, in specific, I can ignore the F3 force or F2 force. Yeah, 2 force entirely, right? Because it just wants that F1, Fr equals F1 plus F3. Right, so sum the forces in the x, sum the force in the y, find the resultant force, and then use the theta equals inverse tangent, right? Now you try on your own, see who comes out with an answer. This just doesn't do anything then. Right. Don't know what that was. So I would recommend you all get a good calculator for this class. You won't be allowed your phones on the exam, so yeah, no, I mean it's fine. It's fine now, but my point is, if you always use your phone and then you go into the exam and you use a new calculator, you're not going to be as fast if you always use your calculator and know where the buttons are, right? So it is a good idea to use the calculator you're going to use on the exam for the class and the homework problems. It just makes it faster. You have a little more time, right?
So they want the components of R and the angle.
Right, so they want FR equals F1 plus F2, or F3, sorry. And it's orientation theta measured clockwise from the positive x-axis. I should read it more in. All right, anybody have an answer? Anybody close to an answer? I'll give you a second.
I got the magnitude of R, 221.6.
I got 222.024, so close enough. Like I said, if you depending on how you round, you're gonna get slightly different answers. You did. I'm guessing you did the steps right. You just rounded to a different digit. I did somewhere. So you guys want me to go over this one?
So what is the final magnitude?
My magnitude was 222.024, and then anybody get the angle?
4.3.
4.26. So yeah, 4.3. Good job. You guys want me to go over it still, though? Yes. All right. So, positive right FRX, right? So since I'm ignoring the F2 completely, I just crossed it out, right? So we'd have that 400 cosine 30 minus 250 sine 30, right? Yes? So you do the math there. I got 221.41 newtons, right? And then upward plus Fy is going to be your negative 400 sine 30 plus 250 cosine 30. And then you put in your calculator, I got 16.506 newtons. After that, you use Pythagorean theorem, right? Fr equals the square root of f rx squared plus f ry squared, right? That would, of course, give you 222.024 when I put it into my calculator. That'll be newtons. And then, anybody tell me how to find theta? Yes.
Arctan.
Right, so tangent -1 of, right, y over x. So if I were to plot this force out, I would go in the positive x, right, and the positive y, which would mean my angle would look like this, right? So if we do, as long as we move this force here, right, we can call this theta, and this tangent will apply, right? Now let's say we instead chose to move the force, leave this force here in the y, right, and then move it over like that. We would have theta here, right? So that will mean we have to do theta equals tangent -1 x over y, right? And then you would take that to get counterclockwise from the positive x. That would go this way, right? You would take that theta and do 90 minus theta, right? To get that clockwise direction. Like I said, it doesn't really matter how you label it per se. as long as you keep up with that orientation and you adjust your answer depending on what assumptions you made, right? So doing it the way in the black writing, we would have tangent -1 of 16.506 over 221.41, and then I got 4.26 degrees. Make sense? Any questions? Everybody got their pictures? Right. 10 minutes, probably have time for one more, right? So, question 11. So if theta equals 60 degrees, determine the magnitude of the resultant force and its direction measured clockwise from the horizontal, right? So the horizontal would be the x-axis. So how we go about doing this one? Anybody know?
211?
Yeah, 211, not 212. Yes.
It wants the resultant,
Yes.
so keep it in equilibrium.
Just if theta equals 60, what's the resultant force?
Oh, so we just do the same component. break it
Right.
down.
So break it down to your xy. Use Pythagorean theorem to solve for r, and then solve for the theta value, right? So since we are running low on time, I'll probably just do this one. You guys can follow along. You would have your right word plus sum of frx equals 8 sine 60 plus 6 sine 40, right? And that would be your 10.785 kilonewtons. And you have upward plus sum. That's terrible. Summation's fine. Plus sum of FRY is 8 cosine 60 minus 6 cosine 40, right? So that would give you negative 0.596. What happened? Right, so it does tell you in the problem that theta equals 60. Yes, that would be a given by the problem. So that would be, so if this angle right here is 60, right? And if I complete this triangle, your sine of 60 is going to be your opposing one, which is going to be this one right here. And then same case for this one, right? Complete the triangle, this is going to be 40. So your opposing one is going to be this side. Alright, so then you would get those two values. You would do FR equals square root of FRX squared plus FRY squared, right? That's going to be 10.801 kilonewtons.
Minus 6 sine 40?
What happened? For which one? Oh, yes, you are correct. Right.
No, it's positive.
Wait. Oh, no, for the x is, yeah, the x is positive. This one goes down in the y, so this one's negative. And then this one goes up in the y. So, yeah, so both rightward forces are positive. I do have it right. I don't know, I make mistakes too, so somebody says it wrong. It might be. So FR equals 10.801, right? So if I do theta equals tangent -1 y over x, I'm going to have tangent of -1 of negative 0.596 over 10.785, right? We can give you a negative 3.163 degrees. So, right, so then it would be theta is, so if I were to have a negative here, right, if I draw it out, so actually what would a negative angle mean here? Well, so if I did, so it would be like this, right? Let me change colors. My resulting force would be like this, right? So I can't see that, right? Like this, right? And that would be Fx, and then Fy would go down, right? So if I were to draw the force, it would look like this, right? So if I want to do tangent of that angle, I'm going to have to move it this way, right? So this means that this angle is going to be going downwards, right? So it wouldn't really make sense to measure it from a clockwise direction because, actually it would, I take that. It would make sense to measure it from a clockwise direction. So you can say that this should be positive 3.163. Because that would mean that I did, this would be y, this would be x. Or did I do it wrong? Negative 0.596, 10. Oh, I think I know what I did. Right, you can't have, when I plugged it in, I left this negative sign here, right? You wouldn't have that negative sign there because it wouldn't make, I mean, it does make sense from this problem, but your y would be a positive force, right? We just put the negative sign there because it's going downwards. So that negative sign indicates it goes down, but that force itself is still inherently positive, right? Because you can't have an absent, like a negative force. It wouldn't really make sense, right? Later on, we do introduce negatives to mean different things, right? So negative is compressive, positive is tensile, right? Right, so you make this positive, which would make your answer positive, and then you would have this as the thing. So, yeah, class is basically over. Any questions before you all leave?